So let's draw just a random picture of some function. Doesn't really matter what it looks like. My intervals are intentionally unequal. It doesn't matter if they are equal, but just to show that what we're going to do, they don't have to be equal for this to work. So some function thrown in there. It doesn't really matter what it looks like. And we got interval from A to B, interval from B to C. And today we're sort of going back to, not sort of, we are going back to thinking about the exact area. So not an estimate. We're not going to do a left-hand sum or right-hand sum where we use the height at A or the height at B and get an estimate. We're going to talk about the actual area of that. And the actual area would be the integral from A to B of f of x dx. So this is sort of going back to what we talked about Tuesday. Just the integral from A to B means the area under the curve from A to B. What would my purple or red area be? How would I represent that with an integral? Integral from B to C of f of x dx. So that's old news, but it's an important reminder for what we're going to do today. And if you understand just those two pieces, most of the rest of this is going to make perfect sense. Famous last words. Properties. The integral from A to B of f of x plus g of x. So I got two functions, I'm adding them together, and I want the total area under if I add them together. Well, maybe this makes sense. I hope it would make sense. That area would be the same as if we took them separately and added their areas together. It kind of makes sense that you could add areas. And B goes with it. You could subtract areas as well. Alright, part C. If I multiplied the function by k being a constant, a number, so I multiplied all the y values by 2. Think about this picture. If there was a 2 out in front of f of x, I guess I should have labeled this f of x. If there was a 2 out in front of that, what would that do to the graph? What would a 2 out in front do? Parent function experts. To increase it, it would double its height. It would increase its height. So if I doubled its height, what would that do to its area? Double the area. And so that k can slide out front. It would double the height, which would double the area, so we can just slip it out front. If you look carefully at D, I bet most of you could figure out what the answer to D is if you look very carefully at those limits and think about what that would mean on the graph. The integral from A to A of f of x dx. So that means the area under the curve from A to A.
Is that just a point or like a line?
So you could argue that it's a line. You could say it's the line. It's sort of that boundary marker at A. You could argue that. How wide is a line? It's like you never thought about that before because lines don't have width. They don't have, that doesn't make sense. They don't have a width. So if a line doesn't have any width, or the width, or even better maybe, the width of that interval from A to A, the width is 0. So what's the area? 0. There is no area. Property E, I don't think you could get on your own. What's different about E? What do you notice about E? The letters are reversed. Good observation. When stuff gets reversed in math, how do we usually account for that? Negative. So you did get it. So if I reverse the limits, it's sort of like I'm going backwards. Instead of saying it's the area from A to B, it's the area from B to A, which is backwards. That's the negative sign. And as weird as that property is, that might be the one we end up using the most, because students and teachers usually want to read left to right. They want to go from A to B, not from B to A. And so if it looks wrong or weird or backwards, well, fix it. And the only price to pay for fixing it is putting a negative sign out front. And so that's a small price to pay to make the limits the ones that you want. And so you'll end up using this quite often the course of this year. All right, one more property that's not on there for some reason. The integral from A to C of f of x dx. So we look at our picture here. Maybe I should have started with the right-hand side, but that'd be the integral from A to B plus the integral from B to C. The area from A to B plus the area from B to C would be the whole area from A to C. All right, some sample problems here. Look very carefully at model problem A. What's the answer to that? 0. Good. Even if you forgot what the graph of sine looks like, it doesn't matter, because if you're going from pi to pi, well, that width is 0, so there's no area there. All right. B looks bad because I'm thinking, at least my initial thought is, well, those are out of order, and x plus 2, that's going to make like a trapezoid, but they gave us from 0 to 3, it's 21 halves. So from 3 to 0, negative 21 halves. Part C, or example C. But note that they've given you some integrals to work with, some areas to work with. So before long, like by the end of next week, maybe the week after that, we'll be able to answer C, D, E, F without that given information. We'll be able to do those on our own. But for right now, we're focused on properties, so they gave us some information. So what do you think the answer to C is? Just make it negative, like take the negative out front, and then you have the answer to what's left. So negative 26 thirds. for part D. Let's pick on some people. Don't do that often enough. Some people talk a lot and others don't. Emma, what do you think for D? Good, you can move the 4 out front. You're even showing your work here. So Andrew, what would my final answer be then after I move the 4 out front? $16, because what's left is 4. There's a 4 out front, so 16. And that's showing a lot of steps. After you do some of these, you're just going to jump to 16, and that would be okay as well. Lauren, how about E? You can tell me what to do, or you could just give me the answer, either one. -6. Because that -3 can slide out front. And then they told us what this part is. -3 times 2 is -6. Alright, part F kind of puts everything together. So why don't you try part F, since it's the last one. So there's answer F. Left as a safe stop. You could clean that up if you wanted to, but why bother? One slight correction on the worksheet on the back. On number 12, I need to break that into 2 pieces, or 2 problems. Otherwise it doesn't have an answer. So answer 12 if F is even, and answer number 12 if F is odd. Do you remember what even and odd mean?
It's the number of like, I know, something else.
Remember what an even function looks like? Or even an example of an even function? An even function has y-axis symmetry. And an odd function has origin symmetry. And maybe that will be, it should be enough. We'll find out if it's enough. Alright, so your assignment with the rest of the class period, 25 minutes left still. Might be able to finish this. Again, note, like at the top, you've seen this already maybe, but 1 through 8, like they give you some information, so you're not having to come up with, you don't have to know how to do that yet. We'll get there, but not yet. Answers are posted in Schoology, so you can check your work.